Hello, today we'll be doing LeetCode problem 1306, Jump Game 3. This problem was made available on LeetCode Weekly Contest number 169, and we'll be solving it today. It's a medium level problem, and you can also find it in the problems page of LeetCode. So let's get started. Given an array of non-negative integers r, you're initially positioned at index start of the array. When you are at index I, you can jump to the right by the value of that index I, or to the left by this value of index I. Check if you can reach to any index with value 0. Notice that you cannot jump outside of the array at any time, and this seems quite obvious because there's no values outside of the array. So after reading the problem statement, I think an example would be nice to go through. Just because the problem statement seems a bit general, we should be able to see what we're required to return and so forth. So looking at this first example, we can see that we have an array, the following, and start is 5, which means that we start at the 5th index. So let's go to the 5th index, which would be this one. Of this 5th index, we have to do the following. We can move from this 5th index to index 5 plus the value, so at index 6, or 5 minus the value, so index 4. So let's say we move to this index 4. Let's proceed by moving 3 to the left. For example, we get to this number 2 at index 1. We can move 2 to the right. So let's move over here and we can reach a 0. So there exists a path such that we can start from the starting index and reach a 0 through this jumping constraint. So we return true. Notice that there's multiple solutions, or there can be multiple solutions for getting to a 0. So for example, if there's many zeros in the array, or if there's just multiple paths to that 0 from start, there can be multiple solutions. So for this problem, we'll only focus on returning true or false. So let's get started. I think that a good way to approach this is, how do we avoid cycles? So for example, if I have a 2 here and a 2 here, let's say I'm at 1 and I try all the possible routes. So I go here, and at this 2 I go to this 2, and at this 2 I go to this 2, so on and so forth, and I keep flipping and I have a cycle that can possibly take forever to resolve. So how do I stop these cycles from occurring? Well, I can have a memory of n, so I can have a visited set such that I can check if I've already visited, if I've already examined this element or this index, no need to examine it again. So I already have the possible routes it can go to, and I've already examined them. So for example, if I'm at this 2 and I check if I've already been at this 2, don't go to that 2. So I think this can be solved with a simple DFS algorithm, such that we can start at start and proceed to many other routes according to this condition. As long as it's reliable and it falls into the constraint, we can keep going and figure out if we hit a 0. And if at any point in that DFS we reach a value of 0, we can return true. So before I like to code this up, let's think of the complexity. This seems like an O of n time solution, because at worst case we'll have to explore every node, and we'll have to check if we have to process every node, in other words. And this also seems like an O of n memory solution, because we need to store a visited set of which nodes we've already seen, and we need, at worst case, that set is all populated. Because we have visited all the nodes, or we visit an order of n of those nodes. So let's create a couple of lines of code. So let's do a couple of corner cases. First, let's check the constraints. So the array is at least 1 length. All right. So let's check, first of all, if array of start, if we are already positioned at a 0. If we're already positioned at a 0, we can return true. Now, if we are not positioned at a 0, the main algorithm comes in. So let's have a visited set and a stack. This is the way I like to perform my depth first search, which doesn't take any recursion stack space. And I can kind of control it with my variables when it's submitted. So let's do the following. While the stack is non-empty, in Python this is a quick shorthand, while stack. Let's do the following. let's take the pop of the stack, and in Python, pop means the last value of the stack. Take it and remove it, store it in v. So in this case, it'll just be start in the beginning. If we haven't processed that v, which is another reason I made this visited a set, because you can check if something is in a set much faster than a list, for example, in Python. So if it's unexamined, let's do the following. Let's add it to our examined nodes of visited, and let's check, is this index that we just stumbled upon, for example, going to the left or going to the right, is it already a 0? Or at any point, did we reach the value that's a 0 at index v, which is the pop? If so, return true, because there exists a path, and we are done. So we're kind of looking at it from a graph perspective of these are nodes, and we use depth first search. So let's try, let's do the other option. If it's non-zero, then we have to go to all of this node's possible routes. So we have to go check if we can move from v to the right without jumping outside of the array. So if v plus the value of v to the right over here is at most the last value of the array, so the last index of the array, that's good. If it's anything more than that, then we can't go there because it's out of the bounds. So we can add it to our stack at the end. So we can append it to the end. Stack.append v plus rv. And likewise, we'll do the left side. So if v minus rv is at lower bounded by the first index we can possibly reach, which is 0, then we can append that to our stack. Stack.append v minus rv. And so we can simply finish this while loop and return false. The reason we return false is because if after all of this stack is empty, if all of the routes have been examined from the depth first search of node 1, of node at index start for generality, then we've never seen a 0. That means there was never a 0 in that path, and we should return false as per the question requirements. So we cannot reach a 0. And let's try running the code. So another thing I'd like to do is run the code before I submit, just to check for nasty syntax errors, as well as some things we may have forgotten along the way. And in this case, it looks promising. We have true and true, so let's try submitting. As you can see, I've submitted quite a bit previously from the contest, and yes, we have passed the solution with 77.35% faster than all the Python solutions and 100% memory. So this is pretty good, and I'm happy with the result. Again, if you have any questions about the solution, please post it in the comments below, and thank you for your time. I hope you enjoyed, and we've tackled number 1306 on LeetCode. Have a wonderful day.